Hi everyone, a warm post-summer welcome to the Handling Failures with NServiceBus webinar. My name is Daniel Marbach and I'm a solution architect at Particular Software based in the lovely Switzerland. And on the other side we have Mauro Servienti, also a solution architect for Particular Software, and he's based in Italy. Let's get started with this webinar. This webinar is based on Elton Stolman's last webinar. We will be doing a brief recap of different failure types, how messaging architecture helps to deal with failure, show that of course in code with NServiceBus, and in the end that all will be rounded up by showing the latest particular platform tools and what the platform tools can do for dealing with failures. Design with failure in mind. Before we dive into the different failure types, we would like to remind you all here to embrace the fact that something will eventually go wrong in your distributed systems. That's a tenet. If you embrace that fact, you'll start designing your systems with failure in mind, and your systems will be more robust and reliable. Please take my Swiss word for that. Hopefully that still counts something. I don't know. So let's talk about the different failure types. The first failure type is a transient failure. Elton showed us what transient failures are. A transient failure can be seen as like a small glitch in the matrix, to use the matrix analogy. For example, a third-party system is no longer available at the time of the request. Transient failures can usually be resolved by doing one or multiple retry attempts. Samples include, for example, third-party credit card providers which are no longer available at the time of the request, SQL Azure database connections, for example, when the connection pool is exhausted due to high traffic. If you design parts of your system to deal with transient failure types, you should always consider a few of these guiding questions. The first one is, how many retries should we really do? Is it 1? Is it 2? Is it 3? How much time should we wait across retries? Is it 10 seconds, then 20 seconds, then 30 seconds? And can we leave the failing messages in the endpoint input queue, and what are the consequences if we do so? The problem is, as always when we design distributed systems, there is no generic answer to those questions. You have to decide for yourself according to functional and non-functional requirements for each business case individually. So let's move on to the next failure type, which Elton described. This is the permanent failures. Permanent failures are more than just a glitch in the matrix, to use again the matrix analogy. It is like the matrix has been shut down, for better or worse. Examples are if a third-party system is failing with a clear permanent error, such as a resource is no longer available, or a bug in the message handling code prevents a specific message being handled successfully multiple times, or a poison message reaches the endpoint's input queue. If you design parts of your systems to deal with permanent failure types, you should always consider these few guiding questions. Is it really worth retrying? Sometimes it isn't, and I'm going to explain when it isn't. Can you leave the failing messages in the endpoint input queue? And I'm truly sorry to say that again, but there are no generic answers to those questions. So consider, for example, a serialization exception. When a message can't be deserialized, there is probably not much you can do with that message because the payload is already corrupted. We might be able to manually fix the schema, for example, through to human interaction on the message, but we would be tampering with input data from other systems, and depending on the criticality of your system, this is not always a desired approach. So sometimes we can't really deal with those messages. It's also letting the failed message in the endpoint's input queue might not be the desired way to go. the endpoint would retry or try to consume that message over and over and over again, but the outcome would still be the same. So sometimes, like in cases of a software bug in a component we own in our system, we are in control of resolving the problem which led to the permanent failure. And if we are, then we can do a bug fix and then redeploy that specific software component and then retry that message, and hopefully the previously buggy component is no longer buggy, and by moving the message back into the input queue of the endpoint which was supposed to handle that message will hopefully eventually be successful. Elton also, based on the interaction with Mauro in the last webinar, we also talked about a third failure type. This is the so-called business failures. Business failures means that the request contains the correct and well-formed data for a specific business request, but the business rules behind the scenes when doing validation against that data are failing. An example could be, for example, when we are trying to create a new customer in the system and the customer is required to have a unique VAT number, but there is already a customer with the same VAT number in the system available. Most of the times those business failures can't be retried, because in that example, when we would retry the same customer with the same VAT number again and again, this would actually lead to nowhere. We would only increase the load on our system unnecessarily. Business failures should not be handled by retry mechanism. It's not a technical problem like the name already says. We should try to handle those business failures with compensation actions. Consider, for example, an accounting system. In the real world, you never erase or remove invalid ledger entry from an accounting system. You compensate the wrong entry with a negative amount of the to be compensated amount. Again, we have a few guiding questions for business failures. Is it really an error? And is it worth retrying? And I think, again, this can only be determined according to your own business domain, and there is no generic answer to that. But how can a messaging architecture, in this example with NServiceBus, help us to deal with failure types? Let us explore a simple architecture, messaging architecture based on NServiceBus system. So we have here a message with the payload 1234 arriving in the endpoint's input queue. The endpoint is here visualized as a green rectangle. So when the message is picked by the endpoint, the user's business handler, so the handler which is supposed to handle that message in code, is executed. When that specific request fails because of an exception, there comes the so-called first level retry. This is this here. So this is handled transparently, directly in memory. If the number of retries configured fails, the first level retry, then the second level retry usually comes into place. If everything failed, then the message goes into an error queue. We usually have a centralized error queue per system. And as I previously mentioned, NServiceBus has the concept of a so-called first level retry and a second level retry. By default, NServiceBus, from a retry perspective, for first level retry perspective, uses 5 first level retries, and for second level retries, it uses 3 second level retries. So what would happen in that case for a permanent failure, it would actually try to retry 5 times here, then the second level retry comes in after 10 seconds, then it retries again 5 times, then it goes back, and then it comes back and retries 5 times. And if everything failed, it goes directly into the error queue. Now, NServiceBus has some smarts internally. So for example, when a message cannot be deserialized, it will bypass all retry mechanisms. So both FLR and SLR are directly skipped, and the message goes directly into the error queues. There is one caveat with the FLR and SLR. So the FLR and SLR can only be configured per endpoint and cannot be configured per message type. In fact, that's not entirely true. It can be overridden, the SLR policy can be overridden on an endpoint, and you get access to the raw transport message, which is provided by NServiceBus. And based on the raw transport message, you could actually code up a second-level retry logic, which is based per message type. We usually recommend our customers not to do that, because we think it's best when you have one endpoint per business scenario, and therefore if you configure FLR and SLR per endpoint, this also holds up for the whole business scenario. In this diagram here, I show multiple input queues. When you scale out a given endpoint, then you have to consider a few other things. Mauro, can you explain that to us?
Yes, an interesting option that especially second-level retries brings to the table is that if you have a scaled out scenario, meaning that you have one input queue, imagine a broker-based thing, so we are running on the Azure Service Bus, or we are running with RabbitMQ. We have one single queue representing our logical endpoint, but we have multiple installation of the same physical endpoint on different machines in order to reach basically high availability and high reliability, and to scale out requests to this huge logical endpoint. What happens is that from the first level retry is attempted always at the same physical instance, meaning that we have this message 123 coming into the input queue, the endpoint instance 1 deployed on machine ABC will try to enter the message. The message may fail, and the first 5 attempts are retried on that exact endpoint instance. When the second level retries kicks in, what happens is that the message, in order to wait for a certain amount of time that by default at the first level, the first second level retry attempt is 5 seconds, is parked for 5 seconds in a persistent storage that can be another queue or something like a database, for example. That means that the second level retry is not necessarily handled by the same physical endpoint that handled the first one. Meaning that after 5 seconds, a new first level retry attempt is done, and then first level retry attempt can be done at the endpoint instance B running on machine whatever. That introduces some interesting thing, that is second level retries are persistent, then can be scaled out, and are highly reliable. Meaning that if during the entire retry cycle one of the endpoints fails, meaning that the machine is dead, for example, we are running in the cloud, and that endpoint instance is killed by the infrastructure, it's not a problem at all. Our message will be a reliable message, and allowing us to basically scale out even second level retries. An interesting consideration, speaking about reliable messaging, we were discussing this thing this afternoon with Daniel, is that in this slide there is this strong statement at the top. So we are saying in a message-driven system, no message can be lost. The question should be, is it really true? As usual, the answer is it depends. So if the entire system is moved forward by messages, losing a message can be an issue. It really depends on the meaning of the message. We have systems where we have messages that we can consider cumulative messages, meaning that a future message will bring the same information as the previous one plus something more. So if we lose something in the middle, it's not a big deal. Or we may have a system where we are not really interested in some business case in having all the messages. Imagine where you have a system where you are logging information using a messaging infrastructure to someone outside of your core business, and that someone maybe is not really interested in having every single thing that happens. Is just interested in having an overall overview of what's going on. So saying that no message can be lost is a general statement that can be true. What do you think, Daniel?
Yeah, Mauro, thanks for clarifying that. So now that we have a general overview over what NServiceBus is doing with endpoints, let's briefly go to the demo. So, okay, here we are on my demo machine. So we see here the same application that was coded before by Elton. We are only showing the version 3 because version 1 and version 2 are still the same. So version 3 is using messaging based on NServiceBus, underneath using Microsoft message queuing. So this time let's do the email and we send up the confirmation again. As you can see on the right side, the message is handled by the endpoint and everything seems to be okay because this is a reliable service. Let's go back and try to use the unreliable service. Let's send that request as well to the backend system. As we can see, the first attempt we did threw an exception. So because we got a web exception, the remote server returned an error, 503, server unavailable. That exception was raised. It was properly catched and handled by NServiceBus, which then triggered the retries. So let's zoom out. The retry was done by NServiceBus. We see here log the full stack trace of the exception. That's of course depending on the log level you use. And you can see here that the second time the request was handled, it was successful and the SMS was sent over our third-party service. So now let's hammer the Twitter direct message service, which is supposed to be unreliable. So let's hit that one as well. So what we see here is it's failing, and we see that their attempt 1 was made. So that was the first FLR, the 5 times it failed. So now the second level retries kicks in after a few seconds. We give it a few seconds. We're not going to wait 30 seconds until everything is done, but let's just wait for the second level retry. That's a mouthful. Until it kicks in. Now it's kicked in and the second attempt was done. So, and this will take some time. So let us briefly walk into the code and compare it to Elton's version with 0MQ. So from the controller perspective, what's only interesting for us is send v3. So what we do is we extract the payload, the HTTP payload. We then create a command, and that command is a plain old CLR object. We put in everything which is necessary, the same as Elton, also hard-code the customer address, and then we use this MVC application servicebus.send. So we are using an evil singleton for this demo app purpose. Please forgive us. Normally we would of course use a dependency injection container. Almost all major containers are supported by NServiceBus, but this is just for demo purposes. So let us see what else we need to do. So we sent the command. So of course in order to be able to send a command, we need to have a configured NServiceBus endpoint. An NServiceBus endpoint is created by a new bus configuration, some configuration code. We are not going to cover this configuration code in this webinar. We assumed that you all have been watching the previous webinars. Of course you have, right? Okay, so therefore we don't need to explain this code. And then we start the service bus, assign the instance to this singleton, to this static property, and then we use it. That's all the magic. Almost. Of course, we need to tell NServiceBus what the name of the error queue is. Remember, I told you we want to have a centralized error queue for each system. So what we're saying here with message forwarding in case of fault config, with that section, we're saying, look, the error queue is here on this local machine and it's called error. It could be also on a remote machine. If it's on a remote machine, then we need to just here add remote machine, but that's really depending on the transport, because we are using here MSMQ with RabbitMQ and other transport. That's not necessary. Then we also configure the audit queue. For recoverability purposes, the audit queue is not really required. We only require that error queue here. And on the other side, we have the handler. The handler is here a simple console application as we have seen previously. That's this one here. And what we need to do is basically the same as we did in our global SX. We new up a bus configuration, we do some magic configuration which we showed in the previous webinars, and then we start the bus. From there on, we are ready to listen to incoming messages. In order to handle this send fulfillment command, we just need to implement the class which implements iHandleMessages, which handles that plain old CLR object, and NServiceBus will take care of automatically dispatching that command to that handler. And what you can see here, and I think that's the main difference regarding recoverability to Elton sample, is in this case we don't have any try catches, counting number of retries, doing some magic timeouts, some header setting or whatever on the message. That's all gone because this is transparently handled by NServiceBus. We just can focus on our business logic in the handler. So in this case, we get the API client, we send and the corresponding request to the API client. Of course, this console as well needs to have the message forwarding in case of fault config section defined, and here as well it needs to match to the centralized error queue. Of course, this can all be set also directly in code. You don't have to use app configs or XML if you don't want to use it. The code also gives you the flexibility to load it from whatever infrastructure you already have in place. For example, you could also directly query it from the database. So that's all. Of course, FLR and SLR is highly configurable. One way to configure FLR and SLR is by using the XML configuration. So there is the transport config, max retries 2. So this means this is the FLR transport config. So in the case of FLR, we will try 2 times at least. It's a bit misleading. It's called max retries, but as Mauro already mentioned, in the scale out scenario, this actually means this is the minimum number of times the message will be retried. Because with competing consumers, it can happen that it is retried on another endpoint. So this you should actually think about not as max retries, so as minimum number of retries. And then there is also the second level retries configuration. You can then say, okay, I want to increase the time, for example, by 10 seconds, and the number of retries should be 3. So it will start with 10 seconds, 20 seconds, and 30 seconds. Of course, you can also configure everything in codes. This is shown here. Let me briefly uncomment this for better readability. Here it is. So in this case, we can say, we can implement a class which implements the interface I provide configuration. We specify the transport config, and there we can set the max retries. For second level retries, we can say, okay, I provide configuration, second level retries config, and we return a new config section with the same settings applied in code, whatever we prefer. And of course, you can also override the second level retry policy, as I told you before. How you do that is you get the configuration object, you get the second level retries config, and then you say custom retry policy, and you provide a delegate which gets a transport message and returns a time span. So as you can see, in this delegate you get raw access to everything which is available on the lowest level of NServiceBus, like headers, like enclosed message types, the payload body, everything is there. So you can implement your own custom retry policy, whatever it fits for your specific business scenario. In this example, we are counting the number of retries, and when we return time span min value, then the message is not retried, and in all other cases we return 5 seconds. That's just a simple example what we could do. As you can see, we get access to the headers dictionary as well here. Okay, that's it from the code perspective, so there is no more magic involved here. So what does NServiceBus actually do when a message is forwarded to the error queue? We can see here when a message is forwarded to the error queue, I can open up that message. Here we have the body. The body is, I'll zoom in a little bit, is the actual XML payload in our example, as you can see. And if we zoom out and get the extensions, this is the headers dictionary, and it provides a lot of information, like also, for example, the exception stack trace, or even more important, the failed queue. So what do we need to do when we want to move the message back into the queue which it was supposed to be handled? So in this case, when we do it manually, we would actually need to open up that specific message, go to the headers dictionary and see the fail queue, and now we know it's fulfillment manager. So we close it, and in this case we would need to pull it over, drag and drop, and put it into the manager input queue. So if we do that, we pull it over, it's now in that input queue, and if we start the application again, it will eventually be picked up by that console. But of course, because it was a permanent failure, it will again fail multiple times and move you back into the error queue. Of course, we could also code that. But if we want to code that, what it means is we need to have knowledge of the underlying transport. So it means we would need to fall back. We would need to fall back to MSMQ if you're using MSMQ. In the case of RabbitMQ, we would need to fall back to the RabbitMQ.NET client drivers or whatever language you want to use, and then read the message out of the queue, determine the destination queue, and then move the message from one queue to another. Of course, the particular platform itself has a number of tools and helpful utilities to do that all for you, and Mauro is going to show that in a moment. But before Mauro shows you that, let's do a brief recap of what we've just seen. So error handling in NServiceBus is on by default. It's a safe by default behavior that we provide. Error management, as you have seen, is transparent to the business code, so there is no try-catch involved, there is no counting of first-level retries, second-level retries involved, except, of course, when you do a custom retry policy. there is no error management code leaking into your business code, so it keeps your business code really focused on the business code, and all the plumbing stuff is all done by NServiceBus. As said, by default, there are 5 first-level retries and 3 second-level retries done. And of course, business errors are a bit special because NServiceBus can't really know what it should do in case of business errors. And we all heard that business scenarios are quite special in regards to transient and permanent failures. So what we should do is pretty straightforward. So make sure that if you have a business failure that you handle messages successfully. You reply to the originator, so to the one who sent the message with, for example, another message. And if a complex process is involved for error handling on a business scenario, you should always code up policies, or how we call them, sagas, to control the whole business compensation actions. So Mauro, let's
thanks.
Let's show what the particular platform offers.
Yeah. So before moving on to the particular platform, I'd like to add just a small comment to what I said before about the scale-out capabilities of the second-level retries. In the sample we are showing, maybe you have noticed that there's a small line in the configuration of both the endpoints, so the sender and the receiver, that says config.usePersistence in-memory persistence. So the sample is not fault tolerant, meaning that we are using in-memory persistence in the sample itself in order to keep the sample simple. And so if you shut down the sample in the middle of a retry attempt, that shutdown will cause the second-level retries attempt to get lost. So don't use in-memory persistence in a production environment unless you are really sure that you can lose something. So we have several options in order to allow you to persist your messages in a persistent storage that most of the time is a database. So can you go back to the slides, Daniel? Thank you.
Of course, yeah.
So we have Daniel has shown us that whenever a message fails and all the retry attempts has been used in order to retry the message, if that message go on failing, that message will eventually end up in an error queue. That error queue is our safe storage where we are sure that we can pick up the message and decide what to do with that failed message. There's a couple of things that we do not want to deal with. Daniel has shown us some tools, some low-level and ops tools related to how to manage MSMQ, but what if you are using a different transport? So imagine a scenario where you are running on Azure and the transport is the Azure Service Bus. We do not really want to deal with dealing with understanding where is the failed message in which queue, how to get access to that queue with using some tool that does not exist, are not provided by the Azure infrastructure. And the other thing we do not want to do is where is the failing message coming from? I mean, the ops team is only required to deal with, we have a failed message, please infrastructure retry that message for me. It's up to the infrastructure to know where was the message when it failed. And more on that, we want to, regardless of the transport and the infrastructure we are using, we want to be able to get details about the error that is causing the message to fail. So basically, we want to be able to extract from the failing message the information that Daniel's shown us using the MSMQ Explorer tool. Basically, the most important things are the failing queue, where the message failed, and the cause of the failure, basically the .NET exception and the entire stack trace. There's another couple of interesting information that we can grab out of the message headers that are the number of attempts before the message end up to the error queue. And if we have already retried the message at least once. So basically we have this concept of repeated failure, meaning that we can know that, well, we have a failing message, it ended up in an error queue, we retried it once, and it is failing again. So maybe we need to dive into the issue in order to understand why we have not solved the issue, the original issue. And what the particular platform provides us are a couple of tools mainly related to the operations environment that allows us to, first of all, hide from the ops people the transport that we are using. So as we shown before, okay, thank you, Daniel. So let me just reduce this and go back to the input queue. So we have this queue with messages, and if I can, we have the error queue with 5 messages that are all the attempts that Daniel did during this demo, and we still have the application running and in the same state where we left it before. One thing on the Daniel machine that is not working at the moment is a tool called service control. Service control is basically the backend of the particular platform, and the role of service control is to monitor the error queue. Basically, service control is an NServiceBus endpoint whose input queue, whose one of the input queues is the error queue. Service control, as soon as I start service control, and let it start, you'll notice that if we refresh this queue once it's started, all the messages in the error queue will disappear. If we're lucky enough. But let me see if I click. Okay. The error queue is now empty. What service control has done is that it's looking at the error queue, it picked up all the messages and ingested all the incoming messages into its own database. The interesting thing is that since we have, in this specific case, a transactional transport and the transactional database that's one using service control is reliable as well. So if something happens while service control is dealing with a failed message, that message can't be lost, because that message will end up staying in the error queue until service control is capable of ingesting it in its own database. Once service control is started, what we can do is basically use a web application. We don't need this anymore. Use a web application called ServicePulse. ServicePulse is the web UI from the ops perspective of service control. And if I click on dashboard, then maybe I need to, yeah, okay. Let me refresh this because we recently restart service control. What this UI is showing is that we have 4 failed messages, that are messages that have been ingested from the error queue. And it's showing also a list of events that happened in the system that service control is monitoring. We can click on the failed messages icon, and we can see that we have a group of 4 failed messages. We have the first fail was 7 hours ago. Basically, the first time that Daniel ran this demo on his machine was 7 hours ago. So since the same message is failing all the time and we are seeing the same error, basically ServicePulse service control is doing that. But ServicePulse is capable of showing us that we have these messages failing for at least 7 hours. And the last fail time was 10 minutes ago. The interesting thing is that messages are grouped by error type, so we can click on a group and view a list of failed messages, and within this list we have some of the messages that have this repeated failure. So we know that we have already retried that message more than once. From the ServicePulse UI, what you can see is that we have this exception message that is basically the error, the top level error in the exception stack trace. So if you think about raising your own custom exceptions, for example, at the endpoint, at the ending get point level, if you write something like throw new application exception, adding a custom message. That custom message will show up in this UI. What else we can do is click on the show stack trace icon, and we end up accessing the entire stack trace of the failing message. The last thing we can do, and this from my point of view, it is the most important thing, is that we can select the message and retry that specific message, or we are showing for the first time this refresh of the UI of the service control, the ServicePulse UI that we just released. We can retry an entire group of messages. So we can go back to the error group, and given a group of messages, we can hit the retry group button. And what happens is that in a few seconds, you'll see the console application start ingesting messages once again, so that they will end up failing one more. So it's not really, the intent of the demo is not to show, okay, they are failing once again. So if now I stop service control, what happens is that the messages will end up failing and will end up failing once again in the error queue, so that we can see that everything is working as expected.
Mauro, do you allow me a quick second?
Yeah, absolutely.
We have a question from Harsh. It's ServicePulse has been very hard to use as a tool to search for messages and retry them in bulk. I think what you just showed, the grouping capability of the latest ServicePulse and Service Control release, might answer that question. Do you think you could elaborate a bit more how we group by exception type, by stack trace, to maybe get in detail of this question a little bit more?
Yes, basically we realized on ourselves that if you have, in most of the time when messages start to fail in a production system, you will end up with a lot of failed messages. So if something is not behaving as expected, it's not just a single message that is failing. It's really rare that you have sporadic failing messages. So basically we are in the process of the redesigning, because we have more feature that will end up in ServicePulse in the next few months. And we decided to start from the message retry scenario, where you can group messages by stack trace, basically, or by exception type, and you can decide to retry messages given that group. So that's the most important thing. We entirely redesigned the retry engine at the service control level, so that now there is no, if you have ever used the service control and ServicePulse before, you may have noticed that there's a little delay now between when I hit the retry button and once the messages reached the failing endpoint. What is happening is that behind the scenes service control is setting up a set of engines and attempts in order to guarantee that even if in the group that we are retrying there are thousands of messages, up to hundreds of thousands of messages, it's not a problem from the service control perspective, especially if you are running against the transactional transport. You may end up, in previous version, you may end up facing rollback due to transaction timeouts. And there's a question that is, what is the version you are using in this demo? From the service control point of view, it's the 1.6.1, and the ServicePulse API, I do not know which is the correct version, but it's the one.
It's 1.2.1.
Okay, thank you, Daniel. It's the one that you can install using the platform installer right now. It has been released a couple of days ago.
If you allow me,
yep.
Sorry?
Yeah, I saw that there's a question related to what persistence is behind service control. Actually, we are using RavenDB. So RavenDB is the database that is powering the service control storage, and we are using a RavenDB embedded instance in order to specifically simplify deployment. Service control supports scale-out scenario using Windows clusters, since RavenDB supports that. You can make service control highly available and highly reliable using Windows clusters. Daniel?
Yeah. So there's another question. When endpoints are hosted as worker roles in Azure Cloud, Azure Transport and Storage, is ServicePulse still of help? What is recommended in this scenario? An example, no virtual machine. So Kevin, you're talking about platform as a service, right? Only. So no infrastructures. Okay. Okay. Mauro, can you elaborate?
Yes, there's a lot of help that ServicePulse can bring to the table. Basically, if we have every single endpoint deployed as a worker role, configured to use the same error queue on the Azure ServiceBus or the Azure stable storage storage queues, we can then configure service control deployed in a VM to monitor that error queue using the Azure Transport, and then have ServicePulse deployed and connected to that service control instance. So we can use the ServicePulse monitoring UI in order to achieve the exact same goal that I achieved in this demo running on a set of Azure instances. Actually, the requirement is that service control can't be deployed in using a Azure worker role. It needs its own virtual machine. One thing that can be done, since it's available and supported on Azure, is that error queue is consumed by an on-premise instance of service control. So if we do not want to deal with virtual machines on Azure, we can have in our own data center service control and ServicePulse installed, and then consume messages from that error queue. There will be an obvious larger latency, but it will work without any issue.
So there's another question regarding the service control database. I'm going to answer this. Can I use the other database providers for the service control? It's from Eugene. No, it's currently the design of service control. Service control is pretty much self-contained, so it uses an embedded version of RavenDB, and it's tied to RavenDB. We currently do not have it on the roadmap to support other database providers, but we will see what the future might hold. So we have some plans regarding the service control storage, but at the moment it's too early to say anything concrete about that. I hope that still answers your question, Eugene. So the answer to your question is actually no, not yet, and we don't know if we're going to support it. The other one from Harsh is that ServicePulse versus ServiceInsight, what to use when. I think it might be worth to do another webinar on that topic, but just briefly. As we see it, ServicePulse is primarily for the ops, so to monitor your endpoints, see if they are up and running, and for quick retries. And ServiceInsight is more our advanced debugger into the distributed system. So what we usually see is ServiceInsight is used more by developers, and ServicePulse is used more by ops or DevOps people. But I mean, we've seen people using ServiceInsight to do the same as ServicePulse. So sometimes the features do overlap a bit there.
Yes, exactly. If I can add a comment on that, Daniel, basically you can do from ServiceInsight what I just did from ServicePulse. Given that these two tools target two different personas, from ServiceInsight, for example, you can search for a message that can be a failed message. You can retry that message, but you can't retry a group of messages. So given that ServiceInsight is mainly taught as a developer and debugging tool, there's this somewhat of overlapping feature, but does not really work exactly in the same way. Given that both tools relies on service control as a storage, they are showing exactly the same information. So the stack trace you can see from ServiceInsight is exactly the same stack trace that you are going to see from ServicePulse. And as a recap, service control, as we said, is the under-the-hood tool that monitors error queues. It's just basically a plain NServiceBus endpoint. We have a couple of interesting abilities at the service control level that I'd like to introduce you in a second. And then we show ServicePulse, that is the Ops DevOps monitoring tool. ServicePulse is a web application. It's a single-page application. At this moment, can be deployed on the developer machine, but most of the time will be deployed on servers in the test environment, the production environment, or whatever environment you'd like to monitor. There's a couple of interesting things that service control can do for us in a live, especially in a live system. That is one of the most interesting questions that we had last time with Elton was related to how can the UI, for example, in the sample that we just ran, react to a failing message. And there's enough meat on the table to create a new webinar, as we were thinking with Daniel. But basically, we have this feature called service control events. Being an NServiceBus endpoint, what we can do from our system is to subscribe to events published by service control. And service control will publish events based on what is happening in the system that the service control is monitoring. So whenever a failed message reaches the error queue and service control ingested it in its own database, it publishes an event saying, I have a new failed message, bringing within that event all the details related to the just failed message. We have several different events that can display that can show how a system is behaving. But since we are speaking about failed messages, I decided to concentrate on that. What we can do from the web UI that we just showed is to register for that event, and based on these events, report back to the user that something was not behaving as expected. I was just looking if there's some other question that we haven't answered yet, but to me it seems that we have gone through all the questions. Daniel, if you have nothing more to add, I'd say that we can.
Okay, then on behalf of Mauro Servienti from Italy and Daniel Marbach from Switzerland, thanks again.
Thanks everyone.